Hello, and thank you for joining us for this Material Science Heat Treatment Lab. My name is Ryan Trembath.
And my name is James Simpson, and to begin this lab, the materials that you'll need to collect are a pair of long-handled needle-nose pliers, a couple of bobby pins, a cup of water, and a propane or butane torch.
The purpose of this lab is to explore the effects that quenching and annealing have on certain metals. Quenching is the process of heating and rapidly cooling, in this case with a cup of water, and annealing is the process of heating up and slowly cooling the metal, most likely in ambient air temperatures.
To begin the lab, you want to grip one of the bobby pins at the open end with your needle-nose pliers. You'll then begin to heat the very tip of the bobby pin where it begins to loop over. The area that you want to heat the bobby pin in is at the inner cone of your flame. That's the hottest part of the flame and will produce the best results. You'll want to get your bobby pin to be either orange or red hot. And when you get to that point, quickly reduce the flame and stick the bobby pin into the water. For right now, we'll just set that aside. That process was known as quenching. For annealing, begin the same way as quenching and heat the bobby pin again. Again, we're going to get it until it's red hot, but instead of dumping it into the water, this time we're just going to let it cool. Keep it in the grip of your needle-nose pliers because it's still going to be very hot even after it's not red hot anymore. Once it's cooled enough, set it off to the side again. And now we'll pause to allow you to get to this point in the lab.
Alright, now that you've had a chance to complete the lab, we're going to go ahead and take a closer look at our bobby pins. Here you'll see I have a brand new bobby pin, and you can see as I pull the two ends apart, it still retains its normal qualities. Has a good amount of springiness. It will go back to its original shape. And first we're going to take a look at the quenched bobby pin. As you can see, when I pull the two open ends apart, it snaps very easily. This is because through the process of quenching, when you rapidly cool the heated metal, the grain structures do not have a chance to grow, and therefore we have a collection of very small grain structures. And when a dislocation reaches a grain boundary, the metal will fracture and break. Here we're going to take a look at the annealed bobby pin. As you can see, when I pull the two ends apart, we do not have the same amount of springiness, but also we do not have the brittle fracture that was caused by the quenching. This is because the grain structures are allowed to grow to a larger size when they are not being cooled in water, and we still have we still have more ductility within the material, and it is not as brittle, nor is it as strong as the quenched material would be.
Thank you for joining us for part 1 of our heat treatment lab. Join us again for part 2, where we'll look more deeply into the process of quenching and annealing.